All right, so continuing on with 9.3, this example is going to be about what happens when you have a circle and an ellipse. And basically what happens when you have a circle and ellipse is also true. The strategy is going to be true for anything where all of our x's and y's are squared. This is basically how we're going to do it when all of the x's and y's are squared. These are the possible situations. So you've got obviously not touching, no solution, barely touching, one solution, going through in two places, crossing in two places, and then barely touching in one. So we've got three solutions and then four solutions. So we can get anything between 0 and 4 solutions on these types. So without further ado, let's get on with that. All right, so we have a situation here where we have, this is our circle and this is our ellipse. And we are going to we're going to be using elimination to solve this because we need, so using substitution, we would have to solve for x, for example, and then so we'd have to end up taking the square root of both sides, which runs the risk of losing information, right? When you take a square root, you have to do plus or minus, so you run the risk of losing information. It gets complicated. So whenever we have everything squared, we're going to use elimination instead. So in order to do that, right, we need to get the coefficients of one of our variables to be equal and opposite. We're going to do it with x just because it will give us smaller numbers, right? We don't have to multiply everything by 25. So we're going to multiply the top equation by -3, which you see they've done here. So we have -3x minus 3y equals -78, and then our original second equation. And then adding those together, that gets rid of our x's. 22y squared equals 22, and we can then solve that for y. So dividing both sides by 22, we get y squared equals 1. And then if we take the square root of both sides, we get plus or minus the square root of 1, which is just plus or minus 1. Now bear in mind that plus or minus, okay? So we have plus or minus 1. So we need to plug in both +1 and -1 into one of our original equations. I'm going to go ahead and use this equation. So I know that they've already done it on the screen, but I'm going to write it anyway. So we're going to get x squared. So doing the positive version first, we're going to get x squared time plus 1 squared equals 26. So x squared plus 1 equals 26. Subtracting 1 from both sides, we get x squared equals 25. Taking the square root of both sides, we get that x equals plus or minus 5. Now, if x equals plus or minus 5 when y equals +1, then that gives us two solutions for when y equals +1. We have 5 and 1, and we have -5 and 1. So y equaling 1, +1, gives us two solutions when x is 5 and when x is -5. And then when y is -1, I'm sure you probably already thought about this. When y is -1, this is still going to be 1. We're still going to get plus or minus 5. You can see that here, right? -1 squared is just 1. So we're still going to get plus or minus 5, but we're going to get the solution. We're going to get +5 for when x is -1 and -5 for when x is -1. These won't always be this symmetrical. It just happened that way because positive 1 squared and negative 1 squared are the same, right? You could have a situation, maybe a different shape or something where it's not going to be that symmetrical. But in this case, of course, we were dealing with two very symmetrical objects that are centered in the same place, actually, is why it's working out this way, because they're both centered in the same place. So the main point is, though, that we have two solutions for when y is 1 and two solutions for when y is negative 1. So even though these x's both came out as plus or minus 5, they're each two separate points. So it's not redundant. It's giving us 4 solutions. So I've probably hammered that point home enough, hopefully. Basically, just be careful when you're listing out answers. My recommendation would be list them out as you go. Don't try to figure out at the end which solution went with which thing. So once you plug in 1 and you get plus or minus 5, write those out. And then when you plug in negative 1, get plus or minus 5, write those out so that you can see all 4 answers. And if you're ever not sure how many answers you're supposed to have, you can always graph it, and then you'll be able to see, how many times it crosses that they intersect with each other. If you don't know how to graph conic sections on a calculator, because I haven't taught you how to do that yet, you can use Desmos, because that will allow you to type in y squared. Your graphing calculator won't let you type in y squared, because it just gives you y equals and you have to plug in something. But Desmos will let you type in y squared. So you can just use that if you don't know how to do conic on a graphing calculator. All right, we'll have one more video in this section, so I will see you there.